Hello explorers, it's that time again. It's Advent of Code, finally! And as normal, you can join the channel as a Christmas explorer and see all the uncut content before I publish any video. Day 7, Camel Cards. Your all-expense paid trick turns out to be a one-way 5-minute ride in an airship. At least it was a cool airship! It drops you off at the end of a vast desert and ascends back to Island. Did you bring the pouch? You turn around to see an elf completely covered in white clothing, wearing goggles and riding a large camel. Did you bring the pouch? She asks again, louder this time, and you aren't sure what part she is looking for. You're here to figure out why the sand stopped. The pouch? For sand, yes. Come with me. I will show you. She beckons you onto the camel. After riding a bit across the sands of the desert island, you can see that look like very large rocks covering half the horizon. The elf explains that the rocks are all along the part of desert island that is directly above Island, making it hard to even get there. Normally they use big machines to move the rocks and filter the sand, but the machines have broken down because of Desert Island recently stopped receiving the parts they need to fix the machines. You already assumed it would be your job to figure out why the parts stopped when she asks you if you can help. You agree automatically. Because the journey will take a few days, she offers to teach you a game of camel cards. Camel cards is a sort of similar to poker, except it's designed to be easier to play while riding a camel. In the camel cards, you get a list of hands, and your goal is to order them based on the strength of each hand. A hand consists of 5 cards labeled from A, K, J, T, 9 all the way down to 2. The relative strength of each card follows the order. A is the highest and 2 is the lowest. Each hand is exactly one type, from the strongest to the weakest. They are 5 of a kind, 4 of a kind, full house, 3 of a kind, 2 pair, 1 pair, and a high card. Hands are primarily ordered based on type. For example, full house is stronger than 3 of a kind. If 2 hands are the same type, a second ordering rule takes effect, starting by comparing the first card in each hand. If these cards are different, the hand with the stronger first card is considered stronger. If the first card in each hand have the same label, however, then move on to considering the second card in each hand. If they differ, the hand with the higher second card wins, otherwise continue with the third card in the hand and 4th and 5th, and so on. And then we have, to play the camel cards, you have a list of hands corresponding with a bid, your puzzle input, for example. And then we got this example here. It shows 5 hands with a bid and its rank. And then you first sort them in order. So the first one had 1 pair, so the hands are all stronger type, so it's get the rank 1. The second one has 2 pairs, and it's same with another hand, but one of them is stronger, so the first get rank 2, the other gets rank 3. And then we have 3 of a kind, and those are ranked 4 and 5. So when we have all the rankings, we will take those and we will multiply those with the bids and get the total winnings. So it's pretty much a sorting game and giving things a rank after the sorting. So let's see here. Let's switch over to my code here. So I've already copied in the text. And then we will split that, and I also created a card. So let's create a list of cards. Start there. Cards, new array list, appendable array list, like that. card, import that class, day 7, that, and then cards equal to, or add new card with the line, like that. So here in card, we need to have a public card string line, like that. And here we will need to have an int of a type. We need to have an int of an int array of hand, new int, and it's going to be 5 cards in each hand. We will need to have an int of bid. You can take a long of bid as well. I think we can start there. So in here we'll take a for loop of the characters. Split this into characters. If this equals to A, then we'll do something else. I have a bunch of else. Oh, we do switch statements. That's gonna be great. So we'll do an index here, so we know what to put in. Then we have a switch over C, case A, break, and here we will do hand I equal to 13. Maybe we can make it into one line so it's not that verbose. Whoop. So A, then we have K, queen, 10, 9, 8, 6, 5, 4, 3, 2, and it can't be K and K, it needs to be K and J. So let's see here. Yeah, J. J is used. There we go. And then we should give them different numbers. So 12, 11, 10, 14. It's not super important, but I think it's more readable if I give them the right numbers. Like that. So then we should have hands with a bunch of numbers. We can also have type amount, and this could be an int of 15. And here we can take type amount hand I plus plus, like that. What's the problem here? unreachable statement. Like that. But that we need to assure that type amount this array fill that with 0, so we know that we don't have anything in it. Should probably be 0. Amount. Let's see here. So the types we could have is these types. Five of a kind. Four of a kind. We have a full house. We have a 2 pair. 1 pair. High card. Like that. So those are the ones that we need to figure out here. Those are of course static. We go if 5 of a kind, and then we can break. Four of a kind. And then we have full house. And 2 pair, 1 pair. We don't have 3 of a kind. Oh, we have 3 of a kind. Kind. Like that. So if we have 3, and we have 3 of a kind, 2, 1 pair. So now we could have 3 of a kind and everything, but we could have 2 pairs or a full house as well. If type equals to card one pair. Then type is equal to card 2 pair. And else it's 1 pair. But we could also have 3 of a kind here. Kind. And if that in that case, it's a full house. Then we need to do the same for a 3 of a kind. So if we have a pair, it becomes a full house. And then 4 of a kind. I think we have all of the types here. So if we go down here, index 5 out of bounds for length 5. Yes. Because we have 2 parts here. So string split line array, line split space. And then we will take the first part of the line array here, but 0, and then we will have bid is long parse long line array, that part. That should be 3, can't break that one, and 2, we can't break that one. So now we should make this comparable. With other cards. So if card type equal to type this time, if that is not, then we will return integer compare card type with this type. And if that's not true, then we need to loop through the hand. That hand I compare those two. Like that. Else we return 0 because they are equal. So if we have a bunch of cards here, we should be able to take list, compilation, collection, collections, sort, cards, public, void, set, rank, this rank equals to rank, public, long get score, return bid times rank. And this needs to be field like that. Long there as well if we want. For card in cards, int rank equals to cards size, card set rank, rank, and then rank minus minus. We could take card get score val plus, and then print val down here. We do like that. You get 6,440. And that is the right value. So if we now switch over to the real data here, what do we get? We get that huge number. Let's see if that is the correct number. Yes, you get a gold star. I get a gold star. Everybody gets a gold star. So we have sorted the list. This video series is sponsored, so for all your hosting needs, go to DigitalOcean. If you want to learn something new this Christmas, then you can go to Coursera, take any of those 7,000 courses over there, or follow along with the simple Java course that I provided as well. And if you want to give your kids something really great for Christmas this year, you can give them a one-on-one course with a Code Combat trainer in order to learn coding. All the links can be found in the video description. Part 2. To make things a little bit more interesting, the elf introduces one more additional rule. Now, J cards are jokers, wild cards that can act like whatever card you would make the hand strongest type possible. To place a J card are now the weakest individual cards, weaker than even 2. The other cards stay in the same order. Okay. It stands that you can pretend to be whatever card is best for the purpose of determined hand type. For example, JJ, QQ are 4 of a kind. However, for the purpose of breaking the ties between two hands of the same type, J is always treated as J, not the card it's pretending to be. So J is weaker than because J is weaker than Q. Okay. Now the above example is different. We should check for 5 or let's see here. This plus type amount 0. So the J should be a 0. We should check for this J amount plus the type amount of 0 actually determines what kind of hand it is. Put that in. No, your answer is too high. Yeah, I realized that we can't, of course, check against it's the 0th value and then add it as well. That would be crazy. So that might be it. So we got a different number now. And it's larger than the other one value. Didn't say it was too high. But at least it's a different number. So I will try that as well. Still too high. I realized that I can't use the type amount more than once, because then I can never get 3 of a kind. And I would get, or I can't get a full house. I can only get 3 of a kind two times. So if I use the type amount, I can't reuse it. So if we are here and we have not used the type amount, and if any of these are true, then we have used it. And all these are breaks, but here we can say that we have used it, and here we can say we have used it. Then we will not reuse it. So then we can only check against J again. We don't need to add it down here. Then we should get a different result, hopefully. 4 times the charm. Still larger than the first value. Maybe I found the last bug. So I got another value again. And then the last bug was, of course, the weird case where you have all jokers. Then you have 5 of a kind as well, of course. And then we got an even smaller value. So let's hope that I found all the bugs now. Yes! You get a gold star! I get a gold star! Everybody gets a gold star! We solved day 7 as well. Oh, we had the right idea. We did the right things pretty much, but we didn't handle all the cases and there were a lot of bugs. So let's look at what I actually did here. So first off, we have the reader here. We read in and create a bunch of cards. We will sort these cards, important, to get the right rank. Then we will go from because it's sorted in the normal order with the highest card at top. Then we will start the card size. In this case, it was 1,000 cards. And then for a full loop, we will set the rank and then get the score, which is pretty much the bid times the rank. And then we will decrease the rank. Then we will get the value that we print out down here. These are all the values I have tried. And we wanted to find the smallest value here because that was the right one. We always got the information that you are too high. Go lower, go lower. So let's see here. In here we have first off implemented a bunch of static variables here to remember which card is which. Then we will set just high card as the type. We will have a hand of 5 cards. We will have a bid, which is a long. Then we will also have a rank, which is a long, and we will have something we call a type amount. So the type is the amount of each type. So if we have 5 cards of one particular color or a particular amount, let's say that we have 5 5s, then or 5 6s, then we will have that in this little array here, so we can check if we have a full house and so on. We will fill this type amount array, and then we will split the array up, the line up, because the line is both the hand and the bid. Then we take the second part as the bid, and the first part we split up in characters. And if we have an ace, that's a 14. If we have a king, that's a 13. If we have the queen, that's 12. If it's a joker, we put it at 0. So we will remove all of those. 10, 9, and so on down the line. And we also add the hand amount into a type amount. So we will add to that. Now we need to figure out the amounts that we have to work with. So I just go through all the type amounts and put them into a list instead. And the reason I do that, and also remove all zeros, the reason I do that, and I go from 1, not 0, so we don't have other jokers with us. And I put that into a list so I can sort it later, largest value first. And then we will take the odd case where we have all jokers, that is 5 of a kind. And then after we've sorted this, we will say, have we used the type amount already? So have we already taken the jokers and used those? Then we will go through this list and take the largest value of the amount we have. So if we have 3 5s, then that will probably be the first value we have. Then we have 3, and we might add an extra joker here or 2 jokers. And if the jokers plus the amount of cards that are similar is, let's say, 5, then we have 5 of a kind. If it's 4, we have 4 of a kind. In both these cases, we can't have anything better, so we just break. In the case of 3 cards, on the other hand, where we could have the case where we already have a pair, then we will have a full house. Otherwise, we will have 3 of a kind. And in this case, we now have used the type amount, so we can't put it in again. And it's probably in the case where we have 3 of a kind. And in this case, when we have 2, then we will either have 1 pair. If we already have that, then we will have 2 pairs. And in the case where we have 3 of a kind, then we will have a full house. Otherwise, we have just 1 pair. And we have also used the type amount here. So we will not reuse that. So that was pretty much what we needed to figure out what kind of type we had. Then we have a sort function, which will check the type first and sort on highest type. And after that, we will also sort on the highest hand value of each card. And we go from the first value to the last value and just check which is largest. And if any of them are identical, we will have 2 cards that are identical and return that. In this case, this should never happen, because then we have 2 bids that could be 2 different ranks. That would not be good. And with the set rank and get score value is also very little code. So this was today's challenge. I hope that you found this interesting. I had a lot of challenges with this one. But I finally solved it. I hope that you liked this video. Give it a like, share it with your friends and colleagues. If you have a better solution, leave that in the comment section down below. Or if you think this is very confusing, then there are very nice people in the community that will share their code or their thought of handling this kind of examples. So please read the comments if you want extra information. And if you haven't subscribed yet, please do that. And I really hope to see you in the next video.